So this is a series on carbon capture and sequestration. And if we want to talk about direct air capture, then the biggest technical problem, of course, practically speaking, is that CO2 is only 0.04% concentration in the atmosphere, which means if you want to take out a reasonable amount of CO2 from the air, you have to flow through lots of air and precipitate out that tiny amount of CO2 that's there. What's one way to increase flow through? All these systems that are now run around the world, like Climeworks in Iceland and elsewhere, they have huge fans that suck in the air, take out CO2, and spit the air back out that is devoid of CO2 mostly. But imagine that you want to use all the trains as one example. The train is going from somewhere to somewhere anyway, so it obviously has a lot of air passing by. Can you fit this train with a system that takes the air that is coming in, take out CO2, precipitate out in some way, and then spit out the air that is, lost its carbon dioxide to this absorption and so on. And the idea is really good. This paper looks at also generating the power, energy needed to do this process by putting solar panels on the train itself. Also looks at generating power using the brakes. It's called regenerative braking power. Efficiency can be low, but nonetheless. And also talks about mitigating emissions from diesel. If it's a diesel train, you want to electrify the trains, obviously, eventually. And to be sustainable, you want more and more people to use public transportation, and trains can be one of the modes. Of course, you also can have buses and so on, or buses that fold up the wheels and become a train for the last mile problems, etc., that we have looked at elsewhere. So technically, you can fit these flow-through systems on anything that is moving, keeping in mind that you don't want to increase the drag on the transportation itself so that fuel demand or energy demand doesn't go up. So, this is a very good idea, and they provide some calculations as to how many trains can be fitted with this system going forward in time to scale up to gigatons in cumulative carbon collection around the world. Very nice calculations, maybe a little too theoretical at this point, but there is nothing really impractical about it. So hopefully it will get implemented, tested, scaled up, and so on. We can never stop having fun with innovation, right?